Remember the punching bag activity I had mentioned in the first video? When you apply full energy to your fist and make contact with the bag, it retracts or moves away accordingly. There is a law for this kind of situation. Can you guess what that law is called? If you answered the law of conservation of energy, then you're right. What does the law state? It states that the energy can only be converted from one form to another. It can neither be created nor destroyed. The energy that you produce from your fist transfers to the bag, and the bag uses that energy to move away from your fist. This law can be applied to any type of situation. Let's try out an example. A boy that is on the 4th floor of an apartment wants to play a prank on a man. He takes a water balloon, lets go of it towards the vertical direction on the man's head, and succeeds with a devious victory. Now, aside from the prank, where do you think the law of conservation of energy lies here? Before the boy lets go of the balloon, it has potential energy, and then it turns into kinetic energy when it falls from the boy's hands. So when potential energy turns into kinetic energy, it's a conversion. A conversion from one form to another. And this type of conversion is called the law of conservation of energy. Let's take a practical example now. A boy takes a plastic bottle filled with water with a cap on. He plays with it by squeezing the bottle. Suddenly, the cap pops from the bottle with water spraying on his face. What happened here? Let's look at it in slow motion. Before the cap pops out, it has potential energy of say 30 joules with zero kinetic energy. It has zero kinetic energy as it's not in motion. And just when the cap pops out at a certain position, its kinetic energy is 10 joules and potential energy is 20 joules. The kinetic energy increased and the potential energy decreased. What is the mechanical energy of the cap before and after it pops out? From what we understand about mechanical energy, it is the sum of potential and kinetic energy. Before the cap pops out, potential energy is 30 joules and kinetic energy is 0 joules. If we add them up, the answer is 30 joules, which is the total value of mechanical energy before it pops out. Now let's see how much mechanical energy it has after the cap pops out. The kinetic energy is 10 joules and the potential energy is 20 joules. Total of that will be 30 joules, right? Hey, the mechanical energy for both situations of the bottle cap before popping out and after is of the same value. What does that mean? It means that even if the potential energy or kinetic energy increase or decrease in any situation, the mechanical energy will be of the same value. In other words, constant. This is the law of conservation of energy. Okay, an exercise for you now. A boulder is on the edge of a cliff. The potential energy is 50 joules and kinetic energy is 0 joules. The boulder suddenly falls from the cliff. Okay, stop there. Now, the boulder is in the mid position between the top of the cliff and the ground it is to fall on. Let's pause this animation here. Now I want you to answer these 3 simple questions. What is the mechanical energy of the boulder at the top of the cliff? What will be its mechanical energy at this mid position? And if the kinetic energy of the boulder is 30 joules here, what will be its potential energy? Let's see the value of the mechanical energy of the boulder being on the top of the cliff. If we add the potential energy, which is 50 joules, and kinetic energy, which is 0 joules, we get the total mechanical energy at the top as 50 joules. Now, based on the law of conservation of energy, the mechanical energy will remain constant here. It will be 50 joules again. Were you able to answer the third question? The kinetic energy of the boulder is 30 joules here, and we know that the sum of kinetic and potential energy is the mechanical energy. Hence, the potential energy will be 20 joules here.